G'day Dan, mate. This is the question that you've asked for, question 15, which is a pretty challenging problem algebraically now that I've worked through it, mate. So, look, we sort of haven't spent too much time on working backwards from a graph to an equation, but this is actually a really good problem to get to know because we'll be doing a little bit more of this in the next chapter. So, the first thing we've got to look at is basically drawing a scenario of what's actually happening. Right, so as you can see here, we've got the following information. We've got an x-intercept at 1, we've got a y-intercept at 10, and we know that our turning point, it maxes at 18. We don't know its axis of symmetry yet, but that's part of the process that we need to do in order to discover what's going on there. So I've used the fact that I know my maximum value is 18, so I've started with turning point form, and I've just subbed in the information that I know. So I know I've got 1 and 0, and I've got 0 and 10. So if I put 1 for x and 0 for y in the equation, I come up with equation 1 there. And if I do the same thing with 0 and 10, I come up with the second equation. So naturally what I've got here is I've got two unknowns, a and h, and I'm going to solve them simultaneously, which takes a little bit of work algebraically, but it all comes out okay in the end. So looking at equation 2, if I take the 18 across to this side, 10 minus 18 gives me neg 8, and negative h squared is h squared. If I solve for a, I get negative 8 over h squared. So now that I've got a in terms of h, I'm going to sub that back into equation 1, which is from up here. So again, this is where it can get a little bit tricky, but if you keep your algebra clean, there should be no reason why you can't do it. So in the first step here, I've taken across the 18 and multiplied across at the same time with the h squared to yield that negative 18h squared. I'm then expanding my perfect square on the right hand side here, and 1 squared is 1, double the product is negative 2h, h squared, h squared. I then expand out, gather my like terms, so bring the minus 18h squared across, and that creates the 10h squared there. I create a quadratic scenario, and I divide everything by 2 because I can see a common factor, so 10 becomes 5, 16, 8, and minus 8 minus 4. And then I factorise that guy and solve for h. So by doing that, I get 5h minus 2 and h plus 2, which gives me two separate h values, which is what you're kind of looking at because it's asking you to find two separate equations. So one of these h's will lead you to a certain a value, and one of these h's will lead you to another a value. So therefore in the first one here, if I sub h equals negative 2 into my a in terms of h equation, I end up coming down to negative 2. If I sub 2/5 into this equation, using some multi-story fractions, 2 squared is 4, 5 squared is 25, and then I'll bring the 25 upstairs to create 200 over 4, which is 50. So naturally what I've got here is I've got two separate equations. So f has a value, I've said a is equal to negative 2 from here, and that goes with a negative 2 from there. So remembering that it's x minus h, so x minus minus 2 will give me the x plus 2, and that'll give me the equation for f. And similarly for a and h, for g, we've got a different h value, which is 2/5, and therefore I should get an a value of negative 50. So I've just actually realised that this value of h here, the 2/5, is correct, but I've written it in wrong. So please change that to a minus rather than a plus. Okay, so that should be x minus 2/5 squared plus 18. So that's how you solve this one, mate. It's a bit of a challenge, but one worth knowing, especially going forward. So hopefully that helps you out, buddy. Take care.